Hello everyone. In this video, we are going to study matrix chain multiplication. So the basic concept behind matrix chain multiplication is how you are going to multiply the matrix such that less number of multiplications are required. For example, let's suppose I am having a matrix A having a dimension as 5 into 10, and then I am having a matrix B having a dimension as 10 into 5. So the total number of multiplication to multiply A and B matrix will be equals to 5 into 10 into 5. So if I'm having this A matrix with M into P dimension and this B matrix with P into N dimension, I can say that the total number of multiplication required to multiply both these matrices will be M into P into N. Let us see how. Suppose I'm having this matrix as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is a matrix of 2 cross 5. Similarly, I'm having a matrix as 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. This is of dimension 5 into 2. So to obtain the value, I have to multiply this with this with this has to be multiplied with this will be multiplied with this, and 5 will be multiplied with 9. So you can see that to get two values, I am going to perform 5 multiplications. So the total multiplication cost that I will be getting from multiply this A and this B matrix will be 2 into 5 into 2, where this 5 is the common dimension between the two matrices. Let us understand now what do you mean by matrix chain multiplication when you are having multiple matrices. Now let's suppose you are having a matrix A having a dimension of 2 cross 5, B having a dimension of 5 cross 10, and C having a dimension of 10 cross 2. Now you have to multiply AB and see what all ways you can multiply. You can either multiply A and B together and then you can multiply it with C, or you can multiply B and C together and then you can multiply with A. So I have to find out number of multiplication that I will be getting in both the cases. So now let us see both the cases. So in the first case, I am saying that I am multiplying A and B matrices together. So A and B matrices are of dimension 2 and 5 and 5 cross 10. So the next matrix that I would be getting after multiplying these will be of dimension 2 into 10. And the total multiplications that I would be getting is 2 into 5 into 10, which is equals to 100 multiplication. Then I'm going to multiply this AB matrix with the C matrix of 10 cross 2 dimension, and I would be getting a matrix ABC of dimension 2 cross 2. We would be considering this dimension to calculate the number of multiplications. So this will become as 2 into 10 into 2, which is equals to 40. So the total number of multiplication we got was 140, which is equals to 140. Let us check with this. So first of all, I am multiplying my B and C matrices. So B is of 5 cross 10 dimension and C is for 10 cross 2 dimension. So the new matrix that I obtained was BC of having dimension as 5 cross 2. And the number of multiplication required was 5 into 2. This is equals to 100 multiplications. Now if I'm having a matrix A with the dimension 2 cross 5, then I can say that if I multiply both these matrices, I would be getting a matrix A, B and C with dimension of 2 cross 2. Again, the number of multiplication I would be requiring for this will be equals to 2 into 5 cross 2. This will be 20. So the total number of multiplication I got from multiplying these matrices in this order is 100 plus 20, which is equals to 120. So we can see clearly that from these two costs, this is the lowest cost of multiplication. So we can say that if we multiply our matrices in this fashion, then we will be getting least number of multiplication to get a matrix ABC. This is the formula that we are going to use to apply matrix chain multiplication. So MCM I comma j, if I can write it as MCM of 1 comma n, then this implies that minimum number of multiplication we require to multiply 1 to n matrices. Over here you can see the cost. So this cost is equals to minimum number of multiplication required to multiply 2 matrices. Also note that this is the dynamic programming approach. So we will be using a tabular form to fill the columns along the way and use the values rather than finding it again and again. So let us consider an example. In this example, you can see I'm having three matrices A and B. I'm saying A as first matrix, B as second matrix, and C as third matrix. So according to this formula, we can see that if the value of I and J becomes equals to 0, then the answer is 0. This is because there are zero number of comparisons that will be required as it is just one matrix. So if I write MCM of 1, 1, it means we are multiplying A with A. So basically, there is just one matrix. I'm not comparing anything in it. Similarly, this will be B, B and the value will be 0. Now let's suppose I get a value as MCM 1, 3. So this means I'm trying to multiply A with C. I have to take a K variable according to the formula. So I can write this as MCM of 1, 2 and 3, 3, where 1 is equals to I, J is equals to 3, and I'm having K as 2. So the next value becomes K plus 1. Similarly, I can also write it as 1, 1 and 2, 3, where my I is equals to 1, J is equals to 3, and K can have the value as 1 with other value as K plus 1. Why I am doing this? Because K can take value equals to I or greater than I. So over here I is 1, so K can take value as 1 or greater than 1 means 2. And the K value should be less than J or it can be equals to J. So if my J is 3, it can take the value as 2 or 3 or 1. So this is how I have broken this problem into smaller problems according to my formula. So let us quickly check out another example using this formula. In this example, you can see I'm having four matrices: A 2 cross 2, B 2 cross 2, C 2 cross 3, and D 3 cross 1. I have to multiply A, B, C, D together. So I have to find the pattern in which I can multiply them. I can say that I can either multiply A, B, C together and then I can multiply it with D. Similarly, I can multiply A, B together and then C and D together. And also I can say that I can multiply B, C, D together first and then I can multiply it with A. Further, I can break this problem to AB has been multiplied first and then it is multiplied with C, or I can say that B and C is multiplied together and then it is multiplied with A. Similarly, in this, we can again break this problem into two parts, where first I am multiplying B and C and then I am multiplying it with D, or I can say that I am multiplying C and D together and then I am multiplying it with D. So if I matrices with number 1, 2, 3, 4, I have to find the values of 1, 3 and 4, 4. This will be 1, 2, 3, 4. This will be equals to 1, 1 and 2, 4. This will be 1, 2 and 3, 3. This will be 1, 1 and 2, 3. This will be 2, 3, 4, 4. And this will be 2, 2 and 3, 4. So basically, if I find the values of all these, then I can see that what is the multiplication cost that I'm getting to multiply A, B, C, D.